I'm given that y is t squared minus secant t plus 5 times e to the t. I'm asked to differentiate. So dy dt. Let's say that's 2t minus, and now the derivative of secant. Well, the derivative of secant is secant t times tangent t plus 5e to the t. All right, I found my nice happy derivative. But now let's say someone asked us to find the second derivative. That's the more interesting question. So now I need to take the derivative of this statement. The derivative of 2t is 2 minus, and now I have to take the derivative of secant times tangent. I'm going to think about the constant multiple rule and just let the minus 1 hang out front. And so it's like I'm ignoring it for a minute, just letting it hang out there. And now I need to think about taking the derivative of secant times tangent. And to do that, I need to use the product rule. The first times the derivative of the second, and the derivative of tangent is secant squared, plus the second times the derivative of the first, and the derivative of secant is secant tangent, plus 5e to the t, because the derivative of 5e to the t is 5 times e to the t. So let's see what I can do in here now. Let's see, that's going to be a secant cubed minus secant cubed, and a minus tangent squared t secant t plus 5e to the t. All right, well, let's see if I can do anything with that. My second derivative, d squared y dt squared, is 2 minus secant cubed minus tangent squared secant. So let's factor out a minus secant. All right, and so now I'm looking for anything I can do, and I might be thinking about Pythagorean identities. So let's write them down. The one I always remembered is that sine squared plus cosine squared is 1. And I remember that there are Pythagorean identities involving secant and tangent as well, and we can get those by dividing this identity by trigonometric expressions. So I'm going to divide this equation both sides by cosine squared to start. Sine squared divided by cosine squared would give me tangent squared. Cosine squared divided by cosine squared would give me 1. 1 over cosine squared would give me secant squared. And this reminds me of this expression, but what I realize is I can't really simplify it, because if I take tangent squared away from both sides, that would be a difference that would give me 1, not a sum. So I think that might be where I need to let this problem rest. But let's go on and write down my third Pythagorean identity. Start with this top equation again, and now let's divide everything through by sine squared. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And then 1 over sine squared is cosecant squared. Just a good reminder of our Pythagorean identities. But that's it for now.